So good afternoon, everyone. Good afternoon to all present. Today we will be starting a new chapter. This chapter's name is vector. I'll be sharing my screen now. Okay. So I think you all know the basics of vector. Like I guess you must have been introduced to vectors in physics when you are solving like physics questions, as well as understanding the concepts in terms of vectors. So what actually are vectors? Vector is actually a mathematical chapter, and it is derived from mathematics. It has a sense of mathematics. Let's study what vector actually means. So to understand vector, let's first of all vector, let's first of all understand what is a scalar quantity. So a scalar is a quantity which has only magnitude but does not have any direction. For example, time, mass, temperature, distance, and specific gravity, etc. are all scalar quantities. So what does this mean is like for a particular quantity, we just need to define it by a value. Like if I write a number 6 seconds, so this becomes time, right? So time can be derived only by 6 seconds. You don't say 6 seconds north or 6 seconds south, right? So this is we do not define it like this, right? So this is scalar. So quantities like this is scalar. For a vector which has magnitude, direction, and follow the law of parallelogram addition of vectors. For example, displacement, force, acceleration are all vectors. So how do we understand the magnitude and direction? Okay, let's understand what is magnitude and direction, and then we'll study the law of parallelogram of addition. So this displacement, why displacement is a vector? So consider you are at a point A and you are moving here, right? You are moving here. This is like 45 degree. So this distance is 5 kilometer to point B. So I'll say the guy at point A moved 5 kilometer northeast. Then only I can define where this person reached from this point to here, right? If I write just a guy is moving 5 kilometer, right? So 5 kilometer from point A, 5 kilometer from point A can be on any circle which has a radius of 5 kilometers. So this all point is 5 kilometers away. So how do we know where the boy is going, right? So hence displacement is specified with the magnitude as well as direction, and hence it is a vector quantity. Similarly, this all applies for force, acceleration, and some other quantities as well, right? So let's move ahead. There are different ways of denoting vectors: a bar. Okay, so this is also called as, this is a bar. You can write vector as like this also. Okay, and you cannot write the bold A everywhere, right? You cannot write like this, so let's not try to use it. Mostly you will see we are using a bar with an arrow here, so this will be the general denotation we use for our convenience: a bar, b bar, and c bar to denote the vectors, and a, b, c to denote their magnitudes. Okay, so whenever you see an arrow over the alphabet, this represents, and whenever you see just the alphabet, it represents magnitude of the vector in this chapter. So magnitude of vector A bar is also written as mod of A bar. So obviously we all know this symbol is mod symbol. So mod generally represents magnitude, right? Magnitude can be represented as mod of A bar as well. So a vector A bar may be represented by the line segment OA, and arrow gives the direction of this vector. Length of the line segment gives the magnitude of the vector. Hence O is the initial point and A is the terminal point. So any vector, let's try to understand. If I draw, if I write the point O, here it is my vector, like point A, right? So this, what this point is saying, A bar may be represented. So this vector is actually A bar. So if we know this point and if we know this point, okay, so this is called as terminal point and this is called as initial point. So if we know these 2 points, then we can represent the vector, right? How we can represent the vector, and what, how we'll represent this A bar? This we will represent it by the magnitude. This magnitude will be our magnitude of A bar, and this OA will be the direction of A bar, right? So let's understand some concepts related to vector. Equal vector. So equal vector, whenever you write this A bar, mod of A bar is equals to mod of B bar. So this generally means what? The magnitude of, sorry, whenever we write A bar equals to B bar, this generally means what? The magnitude of A bar is equals to magnitude of B bar, as well as their direction is same, or you can also say they are parallel, right? Two vectors are said to be equal if and only if they have equal magnitude and same direction. You can see AB bar and CD bar has same magnitude. Let's call this as like mod AB and this as mod CD. So these two are equal in magnitude, as well as you can see these two are parallel vectors. So that is why these two vectors are equal. What is zero vector? A zero vector, a vector whose initial and terminal points are the same. So like this is O, and if this is A, so this has some length, right? So that is why this is not a zero vector. But when you have the originating point as O and the ending point as A, so this is what our zero vector. So zero vector has magnitude as zero. Zero vector modulus of zero vector, let's call this as z bar. Okay, so zero vector magnitude is always zero, right? Right, a vector, and when the magnitude is zero, that means the initiation point and the terminal point, initial point and the terminal point are equal, like are same. It's called a null vector. For example, A bar, such vector has zero magnitude and no direction and denoted by zero bar. So this Z bar can also be denoted by zero bar, right? So zero bar, if you determine a point, can you say this point has any direction? Can you determine the direction of this point? Like a point has no direction, right? This is a simple concept. So hence our zero bar is said to have magnitude as zero and no direction. So in vector, there is a concept like, see, for if you start here and after adding few vectors, if you after you add few vectors, when you reach this point again, then you will get answer as zero vector, right? So zero vector will be very helpful in understanding few things further ahead. Let's check. Like and unlike vectors. So two vectors are said to be like vectors when they have same direction. Same direction can be two things, like same direction can be understood in two ways. First of all, they are same, like they overlap, right? And the other thing is they are parallel, right? So same can be understood by parallel, as well as they are overlapping, parallel or overlapping each other, right? Unlike when they are in opposite direction, A bar and minus A bar are two unlike vectors, as their directions are opposite. A bar and 3 by A bar are like vectors. So you can see A bar and 3 A bar. In A bar and 3 A bar, this 3 is multiplied. So only the magnitude has been changed to 3 times. but the direction will always remain. So when there is one more thing that we all need to understand, if you multiply, so like if you write uh, like if you want to differentiate a bar and you want to differentiate 3a bar here, so a bar has a magnitude a, let's say, and 3a bar has the magnitude 3a, right? This is the magnitude, this is the magnitude, but the direction, since the vector only a constant is multiplied, we can say that a bar and lambda a bar always have same direction. What is a unit vector? A unit vector is some vector which has a magnitude of 1, right? A unit vector has a, let's call this unit vector u bar. So mod of u bar will be equals to 1, so then it will be a unit vector. So any unit vector in the direction, let's say you have a vector a bar, right? So any unit vector in the direction of a bar is uh, a bar divided by mod of a bar, right? So a bar has magnitude as a. When you divide that magnitude by the same thing, that magnitude will turn out to be 1, right? But the direction will remain same. So this unit vector in the direction of a bar comes out from two concepts. First is this thing, right? That a bar and lambda a bar is always having same direction, and to make the vector as unit vector, you divide it by its own magnitude. Parallel vectors, what are parallel vectors? Two or more vectors are said to be parallel if they have the same support or parallel support, right? Same direction or parallel support, like this vector is parallel vector, this vector is parallel, here this is parallel, anything like this is parallel, direction should be same. Parallel vectors may have equal or unequal magnitude and the direction may be same or opposite. So this vector is parallel, this vector is parallel. Generally, we call this as anti-parallel as well, right? But the support is same in the same direction as shown in the figure. See here, these all are parallel vectors. Okay, let's move ahead. Position vector. If P is any point in the space, then OP bar is called the position vector. So, like consider this: you are drawing you are drawing a vector in 2D space. You have this plane, right? You have 2D plane where you can denote it through points. So this point is P bar, right? So the position vector is the vector drawn from origin to the point P, right? So this is the position vector of point P, right? So this is what position vector of point P. So whenever you draw a vector in the direction of P from originating from origin, then you get the position vector, right? O is the origin of reference. Thus, for any point A, B, you can say OA bar, and OB bar is the position vector, and to represent AB bar, we all know that you can write it as OB bar minus OA bar. Co-initial vectors are the vectors which initiate from the same point, right? So these all are co-initial vectors. Origin, like the initiation, the point of, like the initial point is same for co-initial vectors. In this figure also you can see OC bar, OB bar, OA bar and OD bar are all co-initial vectors because their point of origin is O. So this point we can define through these arrows, okay? So if the arrow in any of this was reversed, if the arrow in any of this was like this rather than this, okay, then this is not like this won't count as co-initial vectors to the other three, because for this origination point it becomes B when you change the direction of arrow. So this direction of arrow is also Very important. So let's move ahead and see addition of vectors. So vector addition can be done in some ways. So triangle law of addition is one of the ways. So what does triangle law of addition says? So if two vectors are represented by two consecutive sides of a triangle, then their sum is represented by the third side of the triangle but in opposite direction. This is called as triangle law of addition of vectors. So what is this saying? Consider this is, you just first draw a triangle. Okay, now when you draw a triangle, so it is saying that if two vectors are represented by two consecutive sides of the triangle, so if you draw the consecutive sides of the triangle going like in the same direction, clockwise or anti-clockwise, you can choose any. So these two are the sides of the triangle, right? So there, the sum of these two, the sum of these two vectors will be represented by the third vector, but in the opposite direction, right? So these two are going clockwise, right, like this. So the opposite direction will be anti-clockwise, so this arrow will go like this. Hence this is the definition. So let's say this was our a bar, this was our b bar, this was our c bar. So we can write c bar equals to a bar plus b bar. If you make this arrow like this, if you make this arrow like this in the triangle law of addition, we already studied that if you do the same arrow, then if you call this c bar, this is a bar, this is b bar. So this is what, if the direction changes, a bar plus b bar becomes minus c bar now, right? Because c bar is in this direction, so minus c bar will be in the opposite direction. So the sum of the vector will be minus c bar. So from this diagram, you can also find out that a bar plus b bar plus c bar equals to 0. So if all the three vectors of a triangle are added in the same direction, then the resultant is a null vector, which we reach at this point again. So the initial point and the terminal point become same. So you can interpret two things from triangle law of addition. First is this thing where c bar is a bar plus b bar, and the second is a bar plus b bar plus c bar is 0. Okay, this is 0 when same direction. All the vectors are added in same direction. All added in same direction. Now parallelogram law of addition of vectors. So now if two vectors are in this thing, first I'll tell you this is a bar, this is b bar, right? So earlier it was a triangle law of addition because this like this the vector representation was there, right? So these two can be said to be the vector offered, like these two can be said to be the side of the triangle. You can draw the third side and you can understand things. But what if the direction is not the same and it is opposite, right? So from this thing, what we try to conclude is let's draw a parallelogram like this, right? So if this is a bar and if this is b bar, so this parallelogram law of addition of vectors says that when the vector represent the adjacent side of the parallelogram, then their resultant is the diagonal originating from the same point, right? So let's read the statement to understand more. If two vectors are represented by the adjacent sides of a parallelogram, then their sum is represented by the diagonal of the parallelogram whose initial point is the same as the initial point of the given vectors, right? So just now we saw that the initial point is the same for all these three vectors, but a bar and b bar are the adjacent sides of the parallelogram, and hence c bar will also be the c bar will originate from the same point and it will be the resultant of a bar and b bar. C bar is the diagonal. So in parallelogram law of addition, diagonal is the resultant. Sorry guys. In triangle law of addition, the third side is the resultant. Okay. Addition in component form. So now, now if the vectors are defined in terms of I cap, j cap, and k cap, and if a bar, so what is I cap, j cap, and k cap? Let's first understand these three terminologies. So when we draw, like we draw axis in a plane, then it becomes like we have only two axes. So so to draw axis, like to draw points in 3D, we need three axes, right? X, Y, Z, right? So this x direction is represented by I cap, this y direction is represented by j cap, this z direction is represented by k cap, right? So now this a vector is said to have three components, one in x direction, which is a1, one is y direction in a2, one is z direction, that is a3, and b vector is similar b1, b2, b3 in x, y, z direction. So their sum can be defined as whenever you sum two vectors, you remember that you add the same component of same direction. You add the component of same direction, right? So for here you can see that you will add for I cap and I cap, the a1 and b1 are the components, so you add a1 plus b1. For the j cap, a2 b2 are the components, so you add a2 plus b2, and for z cap similarly you add a3 plus b3. So at this way, in this manner, you can add the vectors in component form. Now, let's understand some properties of the vector. So, vectors, like a few properties of the vector are similar to the numbers, and few properties might be different, which we'll study a little further. But these are the basic properties. So, vectors are commutative. So, commutative is whenever you add the vectors, vector addition is commutative, right? So, b a bar plus b bar is equals to b bar plus a bar. So, for addition, the quantities won't change, either you add the x component of first vector or second vector first, or y component or z component. So that is why this a bar plus b bar is equals to b bar plus a bar. So this property is associative property. We also know that vector addition is associative. So in when you are writing a bar plus b bar plus c bar, so whichever two vector you choose to add, a b c or this, right? So for a bar plus b bar plus c bar, you can either choose this, you can either choose this option, or you can choose this option. All option will give you the same answer. So hence we can say that the vector addition is associative. This property is like we can understand that when you add a bar plus b bar, you add the components. So if the components are positive, then it increases the value of all the components, and if it is negative, it might decrease. So obviously, generally we can say that a mod of a bar plus a mod of b bar, sorry, mod of a bar plus b bar is always less than equals to mod of a bar plus mod of b bar. So this you can understand by triangle. So this is like the triangle property, right? So the sum of the two sides is always greater than the third side, right? You draw this vector a bar, b bar. So this, if this is the vector, this is the resultant c bar. So we know that c bar is equals to a bar plus b bar. We know that mod of this, the sum of these two sides will be always greater than the third side. So exactly this property is that. Now here you should understand that this property says that mod of a bar plus b bar is greater than mod of a bar minus mod of b bar and whole mod, because we don't know which vector has a higher magnitude, whether a bar or whether b bar. So that is why we apply double mod. Okay, one mod is outside as well. Now this when you add addition of a null vector doesn't change the vector. The addition of a null vector won't change the vector, and vector like if you add the, see, the first thing is to understand that whenever you add two vectors, this is a bar, this is minus a bar. So when you add these two vectors, you reach where, at this point, right? You first go to this direction, and then you come back again in this direction for minus a bar. So the initial point and the terminal point is same. So hence vector can be written as a bar plus of minus a bar gives us null vector. Vector in terms of position vector of endpoints. Vectors in terms of position vector of endpoints. So if AB bar be any given vector, and also suppose that the position of vectors of initial point A and terminal point B are A bar and B bar respectively, then AB bar can be written as OB bar minus OA bar, which is B bar minus A bar. So AB bar is position vector of point B bar minus position vector of point A bar, position vector of terminal point minus position vector of initial point. So this, like, you can understand here like this. So this is like OA bar, this is like OB bar. So these are our axes, right? So first of all, you know that OA bar is, what is OA bar? Uh, like A bar minus O bar, right? So this point minus O bar, correct? B bar, OB bar is this, let's say A bar and B bar, right? So A bar is generally A bar minus O bar, B bar is generally B bar minus O bar, and AB bar is, whenever you draw this AB bar, right? AB bar is B bar minus A bar, right? Similarly, so B bar minus A bar can be written as B bar minus O bar minus of A bar minus O bar. So B bar minus O bar becomes OB bar minus A bar minus O bar becomes OA bar. So therefore AB bar can be written as OB bar minus OA bar. So this is the proof. Distance between 2 points. So distance between 2 points is similar to this is similar to distance between 2 points. This is similar to distance between 2 points in Cartesian plane, or when we were finding that scalar, right? You remember this is x1 comma y1, this is x2 comma y2. So the distance between these 2 points was written as under root of x2 minus x1 whole square plus y2 minus y1 whole square. So in this only extra thing is we have added z component. So that is why the vector a bar ab bar becomes x2 minus x1, y2 minus y1, and z2 minus z1. So we all know that distance between point ab bar can also be written as magnitude of this vector, and magnitude of this vector becomes under root of this square plus this square plus this square, right? So do you remember the formula? This is formula. So this formula is supposed to be remembered. It will be used in multiple situations. Scalar product of two vectors. Okay. So we read about addition of vectors, but what about multiplication of vectors? So for multiplication of vectors, so you guys should remember that division of vectors is not possible, right? We cannot divide direction, we cannot divide two direction, right? So division of direction is very absurd statement, but division of numbers is possible. So that is why the division is there in scalar, but division is not there in vector. But multiplication can be there, right? You can multiplication can happen. So multiplication happens in two ways. One way of multiplying is a scalar product of two vectors, and scalar product is also called as dot product. The dot product of a bar b bar is represented by a bar dot b bar, and it is written as mod of a bar into mod of b bar cos theta. Okay, cos theta, and this theta is angle between a bar and b bar. So if at least one of a bar and b bar is a zero vector, then a bar dot b bar comes out to be zero, right? If any one of this vector is zero vector, that means magnitude of either this can be zero or this can be zero. When this is zero, if you multiply this and cos theta, you get answer as zero. Now Properties of scalar dot, like scalar product or dot product. So a bar dot b bar is equals to b bar dot a bar. Why a bar dot b bar? We already know mod of a mod of b cos theta. So direction between a bar and b bar won't change, and direction between a bar and b bar is theta. So and direction between b bar and a bar will also be theta, right? If you draw a bar and right, if a bar and b bar, if you take this vector first and type find the direction, it comes out to be theta. If you take this vector first and find the direction, it comes out to be theta again between the two vectors. So that is why mod of b mod of a cos theta, right? So hence these two are equal. So a square, this a square, writing a square is a little poor way of writing this. Let's write it down as a bar dot a bar is mod of a square, right? Multiplication of two vector a square, multiplication of two vector in scalar form, which is a bar dot a bar, like same vector, gives us mod of a square. So why it comes out to be mod of a square? So we know that a bar dot a bar can be written as mod of a bar, sorry, mod of a bar into mod of a bar into cos of theta. So theta between two same vector, like consider this is a bar and this is a bar, right? These two vectors are similar vectors which are parallel. So the angle between them is 0 degree, right? So this becomes cos of 0 degree. So this comes out to be mod a into mod a. So this comes out to be mod a square, right? Okay. So here you can see that when you multiply a constant, you can either multiply to a and you can multiply to b. So this constant will come out. This constant will not play any role. Theta, angle between two vector. To find the angle between two vector, dot product is the best scenario. We all know that a bar dot b bar is mod of a into mod of b cos theta. So cos theta will be a bar dot b bar upon mod of a into mod of b. Theta will become cos inverse mod of a into cos inverse of this particular term. If a bar dot b bar is 0, so there can be three scenarios here. If a bar dot b bar is 0, there can be three scenarios. First is either magnitude of a bar is 0, or magnitude of b bar is 0, or theta or theta can be equals to 90 degree, right? If this is 0, the answer comes out to be 0. If b is 0, the answer comes out to be 0. If these two are not 0, then cos 90 is 0. So that is why you, when cos theta is 90 degree, that means a and b bar are perpendicular to each other, right? So I cap j cap, so we understand this thing. uh, Dot product of two perpendicular vectors is 0. So that is why we all know that I cap, j cap and k cap are represented, like are written for x axis, y axis and z axis, and x, y, z are perpendicular to each other. So that is why I cap dot j cap is 0, j cap dot k cap is 0, k cap dot I cap is again 0, right? See, because these all are perpendicular to each other. Now here a bar dot b bar plus c bar will be equals to a bar. So this is like distributive over addition. You can say that a dot product is distributive over addition. So this thing can be you can normally multiply the brackets. What you will do here is this becomes mod of a bar dot a bar plus mod of a bar dot b bar minus mod of minus a bar dot b bar plus b bar, minus b bar dot b bar, right? So this gets cancelled, and then we get mod of a bar dot a bar is mod of a bar square minus mod of b bar square, right? So if let a bar is a1 I cap, a2 j cap plus a3 k cap, and b1 is this, then a bar dot b bar can also be found out by this particular, like you if I write I cap plus 2 j cap plus 3 k cap and 2 I cap plus 3 j cap plus 4 k cap, then this is a bar, this is b bar, So for this a bar dot b bar, you can simply multiply the components and add them. So this component will get multiplied, this will get multiplied, and this will get multiplied. So 1 into 2 plus 2 into 3 plus 3 into 4. So this becomes what? 2 plus 3, 6 plus 4, 12. 12 plus 18, 20. Right? So a bar dot b bar can be also found out by this method. Maximum value. So obviously a bar dot b bar is equals to mod of a bar mod of b bar cos theta, right? So maximum value of this magnitude won't change, so theta will change, theta can change between them. So maximum value can be maximum of a bar dot b bar can be when cos theta is maximum, which is equals to 1. So when cos theta is 1, this comes out to be this thing, and minimum value will be when cos theta is minimum and cos theta minimum value is -1. So this will be mod of a bar into mod of b bar, right? Any vector a bar can be written as like this. Okay, so we'll understand this. A bar can be written as a bar dot I cap into I cap plus a bar dot j cap into j cap plus a bar dot k cap into k cap. Why we can write this is, see, first of all, we need to remember this particular property where you can multiply the component. So a bar dot I cap, let's say a bar was a1 I cap plus a2 j cap plus a3 k cap. So a bar dot I cap, for this you will multiply only if this, since this there is only I cap, so the other vector is only I cap, right? So this b1 is 1, this is 0, this is 0. So a bar dot I cap will give you a1. So again, for a bar, this x component you got as a1. For similarly, y component you will get as a2. For z component you will get here as a3. Right? So that is why again it becomes a1 plus a2 plus a3. That is why we can write it as like this. Now, algebraic projection of a vector along some other vector. Right? So this thing is actually what you want to find out, the projection of b bar on some vector a bar, right? So what I'll say you is, first of all, the projection of b bar, see, the projection of b bar on a bar will be having length this much, right? And the direction will be in the direction of a bar. So the way I can find it is, see, first of all, a vector, first of all, if I find this length, right? If I find this length, so what is this length in the triangle? We can see this is 90 degree. If theta, so what is cos theta? Cos theta is, let's say this length is L. Cos theta is L upon mod of b bar, right? So we get L is equals to mod of b bar into cos theta, right? Now you know the vector, you know the length of the projection. Now you just need to multiply the direction, right? And the direction is what I can do here is, if I multiply the direction, which is a unit vector in the direction of a bar, into L, right? Then we get what do we get? We get the projection. So here you can see, you just need to find, sorry, we just need to find L. L is mod of b bar cos theta, right? L is mod of b bar cos theta. So L can be also guess. Let's understand it like this. Now we know that L is mod of b bar cos theta, right? What is cos theta? Theta is angle between, theta is angle between a bar and b bar. So we can find cos theta. How we can find? We already studied cos theta is a bar dot b bar upon mod of a bar into mod of b bar, right? So what we can do here is, L will become our mod of B bar into cos theta. Cos theta we can write it as A bar dot B bar. This is into sign upon mod of A bar into mod of B bar. So B bar gets cancelled. So this becomes what? A bar dot B bar upon mod of A bar. Now we all know that mod of A bar, when you divide A bar with its modulus, it becomes unit vector, right? So always remember, a projection of a vector along the other vector is the dot product of that vector with the unit vector in the direction, in like with the unit vector of other vector, unit vector in the direction of other vector. So here this is the formula, always remember this. This is very helpful. Now, angle between two vectors, we already know angle between two vectors. To how to find cos theta can be written as A bar dot B bar upon mod of A bar into mod of B bar, right? We all know how to find mod of A bar, mod of B bar. So let's solve a question to understand this. We are supposed to find the angle between these two vectors. So first of all, to find the angle between these two vectors, let's say this vector is A bar, which is 4 I cap plus j cap plus 3 k cap, and B bar is 2 I cap plus 2 j cap minus k cap. So let's find the modulus. Mod of A bar is under root of, see, 4 square is 16 plus 9 plus 1. So this becomes 25 root 26. Mod of B bar is what? Mod of B bar is 2 plus 2, like 4 plus 4 plus 1, right? So this comes out to be 9, root 9, which is 3. Now, A bar dot B bar, what is A bar dot B bar? A bar dot B bar is equals to mod of into mod of B bar into cos theta. Theta is the angle that we are supposed to find. So what will be A bar dot B bar? A bar dot B bar, A bar dot B bar we can find by multiplying the components, right? We can find by multiplying the components and adding them. So A bar dot B bar will become 4 into 2 plus 1 into 2 minus 3 into 1 equals to mod of A bar is root 26, mod of B bar is 3 and cos theta. What is this? 8 plus 2, 10 minus 3, 7. 7 upon 3 root 26 equals to cos theta. So theta will come out to be cos inverse of 7 upon 3 root 26. So this is how you can find the angle between the vectors. Right? Find the projection of the vector this on the line joining the point this, right? So we already studied how to find the projection of the vector on the another vector. What I'll do is, first of all, we have to find the projection of this vector. So this vector is our B bar, and on the line joining these 2 points, so we have to, like, let's call this as P bar, this as Q bar, right? So our PQ bar, let's call this point as P, this point as Q. So our PQ bar will be 3 minus 5 I cap plus 4 minus 6 J cap plus minus 2 minus of minus 3 K cap, right? So this will be minus 2 I cap minus 2 j cap plus k cap. So right, we got the vector in which we are supposed to find, like we got the vector for which this is B bar and this PQ bar is equivalent to A bar in this particular topic, right? So now we found the vector in which direction we have to find the projection of this vector. So what is the projection of, like, let's say B bar is our let's call Q bar as A bar, right? So B bar is 2 I cap minus 3 J cap minus 6 K cap, and A bar is minus 2 I cap minus 2 J cap plus K cap. Now the projection of this vector is the projection of B bar on A bar. Projection of B bar on A bar will be equals to B bar dot A cap, right? So B bar is, we know that B bar is 2 I cap minus 3 J cap minus 6 K cap dot A bar. A cap is how much? A cap is minus 2 by 3 I cap. So A cap will be this A bar upon magnitude of this vector. So the magnitude of this vector is 3, right? Mod of A bar comes out to be root of 9, which is 3. So that is why we are dividing it by 3 minus 2 J cap by 3 plus K cap by 3. So 2 into minus 2. 2 into minus 2 by 3, we get minus 4 by 3. Minus 3 into minus 2 by 3, we get plus 2. Minus 6 into plus, so we get minus 2. So you can simply cancel this 2, you get minus 4 by 3. So the projection of A bar on A bar comes out to be minus 4 by 3. So if you want to find the length, so this will be like length of the projection will be modulus of this thing, so it will be 4 by 3. Vector or cross product. So like this, let's not read all this and just understand what is like the cross product. So cross product, in this cross product you multiply the direction as well. So to multiply the direction you use the right hand thumb rule and right hand thumb, like sorry, right hand orientation. And if you are multiplying A bar cross B bar, so this is my right hand, you move from A bar and you go to B bar, so this thumb is pointing upwards, right? So this will be the direction of my resultant vector when you multiply cross, when you do the cross product of two vectors A bar and B bar, right? And if it was B bar cross A bar, so B bar is like this, A bar is here, so this will come like this. So B bar cross A bar has a different direction which is opposite to A bar cross B bar. It is coming downward, A bar cross B bar is coming upwards, right? So let's now read the statement. The vector product of two non-zero vectors A bar and B bar whose modulus are A bar plus A bar and B bar is the vector whose modulus is AB sin theta. Okay, so obviously first of all let's understand, I'll write this down. A bar cross B bar is written as mod of A bar mod of B bar sin theta into n cap. This is not dot product, this is into, right? So A bar B bar is written as this. And what is this n cap? N cap has a significance. This is a vector, unit vector. This is a unit vector found by right hand thumb rule, right? So its direction is that of the vector of n cap, right? So the resultant of A bar cross B bar is in the direction of n cap, and this n cap, you understand, right? This n cap A bar cross B bar. So wherever my thumb is pointing in this thumb action, you find a unit vector and you get that n cap. So perpendicular to both A bar and B bar. And always you remember, see, if your A bar is in this plane and B bar is in the same plane like this, so whenever you are doing the A bar cross B bar, you are getting the direction perpendicular to both A bar and both B bar, like both A bar and B bar. So whenever we do cross product, the resultant vector is a perpendicular vector to both the vectors, right? So cross product of A bar plus A bar and B bar will give us a vector in that direction perpendicular to both A bar and B bar. So which we can find out by right hand orientation. By right hand orientation, we mean that if we turn the vector, so we understand now, we are going, if for A bar cross B bar, we are turning from A to B. For B bar cross B bar, we are turning from B to A, right? Okay, let's move ahead. So let's read the last line. Thus, A bar cross B bar is equals to A bar dot B bar, yeah, sorry, mod of A bar mod of B bar sine theta n cap. If at least one of the A and B is zero vector, then A bar B bar is defined as zero vector, right? So A bar should be zero, or B bar is zero, or sine theta is zero. In these three scenarios, you get zero vector as the resultant. So let's study the further topics in the next class, because time is up. I have to take another session. Have a good day, guys. Thank you so much for listening to the class.